All right, so let's talk briefly about bounded and unbounded solution sets. In the previous example, you can see that we have this nice defined region, right? It's got boundaries on every side, and we could take a circle and we could draw a circle around the solution set, right? And the whole solution set could be contained in the circle. So if I took let's see, what color should I use? Black? Here we go. So I could take a circle and I could enclose my whole solution set, right? There's boundaries on every side. That's an example of a bounded solution set, all right? In the previous example, in example 3, we had a region that was unbounded because this, even though I didn't shade, I mean, this shading can go off forever in, in either direction here, right? As long as it's between those lines, but there's no upper boundary here. If I tried to draw a circle around the whole solution set, I could never do it. I'd never have a circle big enough that would contain the whole solution set. So this is an example of an unbounded solution set. Okay, so that's just kind of some vocabulary here. Bounded and unbounded. And it really comes down to, can I enclose the solution set in a circle or not? All right, let's take a look at one more example. So again, we've just got a system of linear inequalities, and we want to determine the solution set, right? So I'm just going to graph the lines and then test some points and then do some shading, right? That's about it. Graph the lines, test some points, do some shading. All right, so now these last two inequalities are probably the easiest to deal with, right? X is greater than 0 on the right side of the y-axis, right? Those are the points that have x values greater than 0, and y is greater than 0 above the y-axis, right? So you can see I didn't even bother drawing the axes out into the other quadrants. I'm only concerned about the first quadrant, right, where both x and y are greater than 0. So that's all I've really drawn anyway. Okay, so all right, so let's take a look at the other inequalities. Those are a little more interesting. So, all right, again, I'm just going to graph the line, right? So let me see. I'm going to make the first one and make it red. All right, so I'm going to create a little table of points, and usually the easiest things to graph are the x and y intercepts. So if I put 0 in for x, I get the y-intercept. So that's just going to be y is 50, right? Because the x term goes away. If I multiply 2 times x, 2 times 0, I get 0, so then x is 50. And if I put 0 in for y, I get 2x equals 50, so this is 25. All right, so let's graph that line. Now I need a bit of a scale here, don't I? So let me switch back to green. All right, so I'm just gonna, I need a fairly big scale, so I'm just gonna go by tens. 10, 20, 30, 40, 50. I don't really need to go, I don't think, any higher than that, maybe. So 10, 20, 30, 40, and 50. All right, so let's graph that line. We know 0, 50 is on the line right there, and 25, 0. Okay, so 25, 0 is here, and I'm just going to connect it. Now, this is a greater than or equal to, so the points on the line are included, so I'm going to graph it as a solid line. All right, so that takes care of the first equation, so that's that one. All right, let's take a look at this other equation. All right, again, I'm just going to find x and y intercepts. So if I put in 0 for x, I get 2y is equal to 40. So y is 20. If I put in 0 for y, then I get 40 for x. All right, so if I just graph the line, I know that 0, 20 is on the line, so there's that point right there. and 40 comma 0. It's right there. Okay, I just need to connect those 2 points with a line. Okay, trying to draw a line. It's not easy to draw lines sometimes. Freehand. All right, so that takes care of that second equation. All right, so we've graphed the lines. Now we just need to test some points. And again, 0, 0 is a good one, right? This is 0 comma 0. Let's use that as our test point. All right, so I'm going to use the test point. Let's use test point 0 comma 0. All right, and so if I test that point in the first line, 2x plus y is greater than 50. So I'm just going to take 2 times 0 plus 0 is greater than or equal to 50. And I just want to ask myself, is that true? So no, right? 0 is not greater than 50. So I'm going to put a line through it telling me, okay, that was not true. So 0, 0 is on the wrong side of the line. I want to shade the other side of the line. All right, so I'm going to put arrows on here to indicate that I would like to, I need points on that side of the red line. Okay, now let's test the other line. All right, again, I can use 0, 0. I'm just going to use 0, 0 because it's easy. So 0 plus 2 times 0 has to be greater than, we're looking for the points where it's greater than or equal to 40. But again, you can see 0 is definitely not greater than 40. So 0, 0 is on the wrong side, so I want to, so the side that I want to shade is going to be that. All right. So now I just want to find the region, the area of the plane where all of these arrows are pointing. So I want it to be above the x-axis, to the right of the y-axis. I want it to be to the right of the red line and also above the blue line. All right, so if I shade the portion where all of the arrows are pointing, it's going to be this area out here. Okay, so that's my solution set. I'm basically showing it graphically because I can't list it all out. I can't list out all of the points. You know, it's an infinite number of points. So we're just showing the solution set graphically. All right. Now, this is an example of an another unbounded solution, right? Because I can't draw a circle. You know, I could draw a circle around what I've drawn, but this plane goes off infinitely in the x and y direction. So you know, I can keep shading all the way out, you know. So this is an unbounded solution because the region doesn't have a nice defined boundary. It has boundaries over here, these lines. The x and y axis and the red and blue lines form a boundary along part of it, but then it's not a bounded solution because it goes off forever in the x and y directions. All right, so that's all the examples I have for you, and so look ahead at the discussion questions. Maybe try a few of those before class, and I will see you in class.